Hello, welcome to this week's topic, nutrigenetics. Let's start off by defining nutrigenetics, which is the study of how an individual's genetic makeup affects their body's response to nutrients and diet. By examining how genetic variants influence processes like nutrient absorption and metabolism, this field provides the foundation for personalized nutrition. In the field of nutrigenetics, there are some core areas of study, which include nutrient metabolism, individual response to diet, and genetic based conditions, both monogenic and polygenic or multifactorial diseases. Let's talk about each of those core topics. First is nutrient metabolism, which investigates how genetic variations impact the absorption, metabolism, and excretion of specific vitamins, minerals, and other nutrients. One example in this area involves variations in the MTHFR gene. This gene provides instructions for making methylene tetrahydrofolate reductase, which is an enzyme responsible for processing folate, converting homocysteine to methionine. One of the most common variants is the C677T variant. Normally, there should be a cytosine at this location, but in this variant, there is a thymine, which leads to altered protein function. The altered function results in higher levels of unmetabolized folic acid in the blood. More people in the United States have one or two copies of the MTHFR C677T variant than don't have it. Additionally, the MTHFR C77T variant is more common in some races and ethnicities than in others. You learned about this concept in a previous lecture about ancestry. In this case, Hispanic individuals are more likely than non Hispanic whites and non Hispanic blacks to have the MTHFR C677T variant. The next core topic is individual response to diet. This area of study aims to explain why some people respond differently to certain diets or dietary components. One example involves people with a variant of the CYP1A2 gene, specifically the SNP RS7625511, with possible alleles being A or C. The CYP1A2 gene provides instructions for making a liver enzyme that is crucial for metabolizing a variety of compounds, including drugs and caffeine. Variants in this gene can lead to people being either fast or slow metabolizers, which alters the effects that caffeine has on their body. People with the AC or CC genotype of RS762551 metabolize caffeine more slowly, making them more sensitive to the effects of caffeine, and they might have an increased risk for negative health outcomes like heart attacks with high caffeine consumption. Other core topics in nutrigenetics include genetic based conditions. In the case of monogenic diseases or diseases caused by variations in one gene, an example is lactose intolerance, which is caused by a variant in the LCT gene. The LCT gene provides the instructions for making the enzyme lactase, which is necessary for digesting lactose, the sugar in milk. Normally, mammals only produce lactase when they are young, but production of the enzyme decreases with age. It is common for people to develop or experience lactose intolerance as they get older. However, variants in the LCT gene can prolong the production of lactase, allowing adults to continue digesting lactose. Alternatively, other variants in the gene can prevent lactase from developing properly from birth, which would cause lactose intolerance even from a young age. This is a good example of the variety of ways mutations or variants can cause issues or provide benefits. A second example involving a single gene is phenylketonuria, or PKU, which is a disorder that results from mutations in the PAH gene. The PAH gene provides instructions for the enzyme phenylalanine hydroxylase that breaks down the amino acid phenylalanine into tyrosine. This causes phenylalanine to build up in the blood, which leads to symptoms such as intellectual disability, seizures, and skin rashes. People with PKU must adhere to a low phenylalanine diet. In relation to multifactorial diseases, there are many nutrigenetic studies examining the predisposition for things like heart disease and type 2 diabetes or obesity. And they're attempting to determine if diet modifications can reduce the risk. One gene that has been studied in relation to obesity is the FTO gene, which we will talk about more in a later lecture. In a review from 2019, the author gathered all the studies pertaining to cardiovascular disease risk and compiled a table with genes that are implicated in increased risk for CVD, as well as the variants within those genes and how they alter function in relation to diet and nutrient metabolism. This is not an exhaustive list, but I have included a few results from the table that we can look at. The ACE gene plays a role in blood pressure, with GG carriers at RS4343 having higher systolic blood pressure than people who have the AA or AG genotype. RS4343 is an identification number for the SNP, or single nucleotide polymorphism, and represents a specific location within the gene. We see that A carriers at RS4923461 in the BDNF gene had higher BMI with higher protein intake compared to those who had the GG genotype at this location. And in the FTO gene, A allele carriers at RS9939609 had a higher risk for obesity, which is exacerbated by high dietary saturated fat intake compared to those with the TT genotype. When you start taking this type of information into account, you can see how, depending on your specific genetic makeup, you might be at a higher or lower risk for certain phenotypes, such as cardiovascular disease, and that diet choices could mitigate or exacerbate the risk. As we continue with this type of research, it will help provide the basis for creating personalized diet plans based on your genetic makeup. In summary, the main goals of nutrigenetics are to understand how an individual's genes influences their response to food, nutrients, and dietary components, be able to develop a personalized diet, prevent nutrition-related diseases, and improve individual health by understanding how a person's genes interact with nutrients. In the next two lectures, we will look at some research that is being performed here at UF in the area of nutrigenetics and how this type of research is done. Thank you.